Visual, the title slide with code melting into neural networks. Voiceover, welcome, everyone. Today, we're talking about a monumental shift in how we build technology. We are witnessing the end of explicit code. We are transitioning from the casual, rapid prototyping of vibe coding to a rigorous new discipline called agentic engineering. The way we interact with computers is changing forever, and the lines of code we used to write are literally melting into fluid, adaptive neural networks. Let's dive in. Visual, graph showing the flip between human corrections and system trust. Voiceover, to understand where we are, we have to look back at what Andrej Karpathy calls the December epiphany. For a long time, AI was just a helpful assistant. It generated chunks of code, and we acted as the human editors, constantly fixing its mistakes. But around last December, a stark transition happened. Suddenly, the code chunks came out perfectly. Manual corrections dropped to near zero. System trust skyrocketed, unlocking a new reality of infinity side projects where the AI handles the entire coherent workflow. Visual, Software 1.0 versus 2.0 versus 3.0 frameworks. Voiceover, this isn't just a better tool, it's a completely new paradigm. In Software 1.0, we wrote explicit rules and precise code. In Software 2.0, we stopped writing logic and started arranging datasets to train neural networks. But now, we've entered Software 3.0. Your programming language is now prompting. Your compiler is a large language model. You are no longer writing code. You are directing an AI interpreter over a vast digital information space. Visual, legacy architecture versus the single Gemini LLM node. Voiceover, what does this actually look like in practice? It looks like the middleware collapse. In the old paradigm, building an app meant stringing together OCR APIs, routing, image generators, and deployment platforms. It was incredibly bloated. Karpathy realized this when he built a menu reading app. In Software 3.0, all of that middle glue simply collapses. You just hand a raw image and a prompt to a model like Gemini, and it directly outputs the final rendered image. That entire legacy app shouldn't even exist anymore. Visual, crossed-out complex bash script versus short text prompt for an agent. Voiceover, this collapse extends to how we set up our environments. We used to write massive, fragile shell scripts trying to account for every possible operating system and edge case. No more. The new way is entirely agentic. You simply copy and paste a block of text explaining your goal to your agent. The agent packages its own intelligence, inspects your specific environment, performs the actions, and debugs itself in the loop. It's resilient, intelligent, and infinitely simpler. Visual, neural network as the host process, CPU as the coprocessor. Voiceover, if we extrapolate this, computing architecture is about to turn completely upside down. Historically, the CPU was the star of the show. But in the future, the neural network becomes the host process. The neural net does the heavy lifting of information processing, and the CPU? It becomes a legacy appendage, a simple coprocessor called upon only for basic deterministic tasks. Even user interfaces won't be hard-coded screens anymore. They'll be unique, dynamic environments rendered on the fly by diffusion models. Visual, graph showing the capability spike driven by verification rewards. Voiceover, so why are these models getting so terrifyingly good at coding specifically? The secret engine is verifiability. Frontier AI models are trained in giant reinforcement learning environments. While traditional computers automate what you can specify, modern LLMs automate what you can verify. Because code and math have objective right or wrong answers, labs can easily generate automated feedback loops. In these verifiable domains, AI capability has simply reached escape velocity. Visual, the 3D landscape of peaks and valleys, jagged intelligence. Voiceover, But this creates a weird phenomenon, jagged intelligence. An AI's capability is entirely dependent on its training data distribution. This leads to an insane reality where an AI can flawlessly refactor a 100,000-line codebase or discover zero-day vulnerabilities, absolute peaks of capability. And yet, in the same breath, if you ask it whether you should drive or walk to a car wash 50 meters away, it might confidently tell you to walk. It excels at complex logic but completely lacks basic common sense. Visual, intrinsic motivation, brain, crossed out, replaced by statistical circuits. Voiceover, because of this jaggedness, we need to reset our expectations. We are not building digital animals. You can't motivate an AI, you can't spark its curiosity, and yelling at it won't improve its output. We are summoning ghosts. They are purely statistical simulation circuits. As an operator, your mindset shouldn't be empathy, it should be extreme suspicion. You must explore the system, map its unwritten rules, and constantly look for its blind spots. Visual, vibe coding versus agentic engineering comparison. Voiceover, as we adapt to these statistical ghosts, two distinct modes of work are emerging. First is vibe coding. This is casual, rapid prototyping that raises the floor so anyone can write software. It's why we're seeing a massive explosion of side projects. But the second mode is agentic engineering. This is about preserving the professional ceiling. It involves rigorous specifications and coordinating stochastic agents to build production-grade software without introducing vulnerabilities. Visual, the red team swarm attacking a deployed architecture. Voiceover, this entirely changes what it means to be a 10x engineer, which means we have to refactor how we hire. Asking candidates to solve basic LeetCode puzzles belongs to the Software 1.0 era. Today's interview should look like this: have the candidate use agents to rapidly deploy a massive project, like a Twitter clone. Then, unleash a swarm of adversarial AI agents, like 10 instances of Codex, to actively attack their architecture. The test is simple: can your agent-assisted system withstand a coordinated AI attack? Visual, the director, human layer, versus the intern, agent layer. Voiceover, this leads us to the new division of labor. Think of the AI as the intern. It handles all the execution, the boilerplate, and has perfect API recall. It remembers the exact syntax across PyTorch, NumPy, and Pandas so you don't have to. But you are the director. You remain in charge of aesthetics, design, detailed system specifications, and the crucial common sense checks, like knowing not to blindly merge a Stripe billing email with a Google Auth account just because they look similar. Visual, human UI versus agent-native infrastructure. Voiceover, as we shift from writing code to directing agents, our very infrastructure needs to change. Right now, our documentation and web interfaces are fundamentally bottlenecks because they are designed for human eyes. We need to rebuild the internet for non-human readers. Workloads must be decomposed into sensors for AI data ingestion and actuators for actionable AI endpoints. The end state is an automated internet where human UIs are optional, and your agents negotiate directly with other agents. Visual, the giant thinking grid versus the singular understanding circle. Voiceover, to wrap up, I'll leave you with a crucial insight. In the era of Software 3.0, thinking is becoming a cheap commodity. Information processing, API routing, code generation, all of this can be outsourced to LLMs. But understanding remains the ultimate human bottleneck. Asking why something is worth doing, establishing taste, and directing the objective, that is on you. Software 3.0 does not eliminate the developer, it promotes them. You are no longer writing the code. You are directing the intelligence. Thank you.